David Smith here with one more Flip Classroom math video. 3 tips before we start. You could turn on the captions and watch my words go by on the screen if that helps. You could also speed up the playback if you can get through the video faster and still comprehend. Lastly, you could pause video at any time and catch up on your notes. Today's video is a further discussion on normal distribution and standard normal distribution and what that means in terms of the bell-shaped curve, finding area under that curve, and what that means in terms of probability. So I'm going to show you how to understand that. Then I'll talk about how to do that on the calculator because there's a bunch of easy ways to do that. And then finally we'll finish off with 4 problems that I'm going to have you pause the video and see if you can do. Okay, so check this out. Normal distribution is denoted as Z. That's a special random variable. Remember, this is a random variable that falls under those 4 constraints that we talked about in the beginning of this chapter. Namely, it's independent. Namely, it's a success-fail kind of thing, like rolling a 6 or not a 6, things like that. And so we use the notation. This is the notation from the last video, that normal distribution, we have mu and sigma squared. Mu is the mean, or the expected. Sigma squared is the variance. Sigma is just standard deviation. So we're going to talk about standard deviation in this particular video. Now, the standard normal distribution is a little bit more tightly constrained. Same thing, but now mu, the average, the expected, is 0, okay? And the variance is 1. Now, if the variance is 1, then you know the standard deviation also. That's 1 as well. So when standard deviation or variance is 1, then the other one is also 1, because 1 squared is 1 and the square root of 1 is 1. So that's what we get. So here is the standard normal distribution. You can always say these 2 things if you're told that it's a standard normal distribution, namely that mu here equals 0 and that sigma here equals 1. Sigma squared equals 1 as well. Okay, now let's take a look at the graph of a bell-shaped curve that shows us this normal distribution, the standard normal distribution. So, as you remember from the last video, we have this bell-shaped curve with a peak at our mean, our mu. Now remember, standard normal distribution, mu is 0. So that's the peak. The data is clustered around the peak and it tapers off sharply on both sides. And then we have, I'm listing my standard deviations along the bottom. So I have -1, +1, 2, and so on. So here's the thing, this is kind of nice, is that we can calculate the probability that a given random event, as long as it fits the constraints for our problem, by calculating the area between 2 points on the standard deviation. So what I've shaded there is the area between -1 and 1. That means that the area under this part of the curve is the probability that a random event will fall between, well, actually, let's say it this way, will fall within 1 standard deviation of the mean. So here we go, area under curve is probability that a random data point is 1 sigma, 1 standard deviation away from the mean. And that's how that works. Now we've calculated probability a lot of other ways. We haven't done it in terms of calculating area. Now the cool thing about your calculator is that it can do that without you having to do a whole lot of math. You just have to plug in the parameters and it will tell you what that area is. Now here's an interesting thing. This standard normal distribution is so prescribed that we already know that the data between 1 standard deviation from the mean, that's 68% approximately of the data is 1 standard deviation away. That would be 68. And it's like 95% is within 2 standard deviations. So I could draw this out. Something like that. It's about 95%. So with a standard normal distribution, no matter what the scenario is, you've got a 95% chance that any randomly generated data is going to be within 2 standard deviations of the mean. Now this is just the territory. This is just where we are. This is like driving into your town and knowing that the supermarket's over here, the drugstore's over there, the high school's down there. This is just the territory of this topic. We haven't calculated that, although people have, but we just accept that, just like you know that the drugstore is where it is. Okay, so maybe pause the video, digest that a little bit, make sure that your notes express any side comments that you need to make sure you understand that. Think about it. If you're still struggling with that, you might pause the video and pop onto YouTube or somewhere else and take a look. You could also read our textbook, although I think it's a little thick, it's a little dense, but you might get some things out of that as well. When you're ready, come on back and we'll talk a little more. All right, now hopefully you spend a few minutes and you figured it out and you kind of put it more solidly in your brain. You asked yourself some questions. Maybe you went down the hall or down the room to find somebody else and ask them some questions. My hope is that what we just covered there makes a lot of sense to you. So let's take a look at the types of problems that you might have to do and the prompts that come with those. All right, so the prompt might be find the probability. The prompt might be find the area under the curve. Those two things mean the same thing. Okay, so here's what I've put. Find the area under the curve for data 2 or less standard deviations away from the mean. Now I've already told you what that is over here. We know that 95% of the data is within 2 standard deviations of the mean. So the area under the curve is going to be 0.95, which gives us a 0.95 probability. Now I'm going to have you calculate that on your calculator for practice, but I'm just referencing that. Now before I turn you loose on all these problems, I want to talk a little bit about how to use the calculator to do that. Now I'm going to drop a couple links in the description for this video. They're the same 2 links I put in the last description, but they're there for you, and it's a little bit more of a look at the calculator kind of walkthrough for how to do this. They're by other people, they're already out there and they work, so I didn't record any new ones for that. But let's take a look at what they're going to have you do, okay? So first off, here is the command line for that. You can just type this in to either the Ti-84 or the Ti-Nspire, and it will do the right thing. It's the same syntax. So let's take a look at that. It's just norm, N-O-R-M, C-D-F, parens, and I wrote LB for the lower bound, UB for the upper bound, and then mu, that's our mean, and our sigma, that's our standard deviation. Now, for these problems connected to this lesson, this is always going to be 0, and this is always going to be 1. So really, what you have to specify is what is the lower bound and what is the upper bound, okay? So there's different ways to operate that to get this in the calculator. If you want to type this in direct, then it's the same on both of these calculators. However, the calculators recognize that typing all this stuff in can be a little bit of a pain, and maybe you want sort of a user-friendly interface that will help you do that. So here's what that is. On the Nspire, what you want to do on the home screen is press the calculation menu, then or button, spot, then press menu, then press 5, then press 5, then press 2. Now you want to watch what those menu options are as you go by, because it's descriptive of what the process you're going to do is. But you're basically going to press menu 5, 5, 2. Then you're going to have a screen where you can enter all 4 of these parameters, and then you're going to press OK. And it's going to give you the answer. And when you see that on your screen, you're going to see this text with your parameters in there, and you're going to see an answer. It's going to tell you what that area is. Now, on the 84, it's a little different. You press the second and the var button. And the second of the var is really the dist, D-I-S-T, for distribution. So you press second var, which really means you're pressing dist, press 2, and then from that screen, you're going to be able to enter all your parameters. So you can enter your lower, upper, your mu, and your sigma. And then finally, you're going to press the paste button, which will put this text into the command line, into the calculator, and then you press enter, and it will calculate, and it will give you the same thing. It'll give you the area under the curve, or the probability that any randomly selected or generated data will fall within the lower and the upper bounds. Okay, one last thing. Sometimes you're asked a question like, what is the probability that a data point will fall further than, say, 2 standard deviations from the mean? So what that means is your upper bound might be 2, but your lower bound is essentially negative infinity. You want everything that's further away than -2 standard deviations. Now, on the Ti-Nspire, if it's a more modern one, you can actually enter in negative and positive infinity, so you don't need to do any special tricks for that. But on the 84 and then on some versions of the Nspire, you can't actually enter that. So what you're going to need to do is fake out the calculator and put in this. This is -1 to the 99th power. So this is a hugely negative number, and this is 1 to the 99th power. The little e stands for exponents. It stands for times 10 to the. So this is 1 times 10 to the 99th, which is 1 with 99 zeros, ginormous number. So either very negative, very tiny, or very large, very positive. That's how you fake the calculator out to say, basically, I want it all the way to negative infinity, or I want it all the way to positive infinity. Now, I know that's a lot. So perhaps pause the video for just a sec. Take a look at your notes, maybe rewatch some of that, make sure this all makes sense to you, because the next thing we're going to do is do some calculations. Okay, I want you to pause the video now and do this first calculation. So I'll walk you through a little bit, and then I'm going to turn you loose. So you want data that is 2 or less standard deviations from the mean. So in terms of this script here, the normal CDF, you're going to put in -2 for your lower bound and +2 for your upper bound. And then your mu is 0, that's your mean, and your sigma is 1, that's your standard deviation. So if you were to type it in, if you want to try that, you can just type that straight into the command line. You can type it just like that. If you want to use the menus to jump through it and have that little input screen that kind of guides you through the process, you could do that too. But what I want you to do now is pause the video and come back when you've got a number. And I said this was roughly 95. It's not actually 95. So pause the video, do the calculation, write down what you really get, and come back and we'll talk about it. All right, so when I do this on my calculator, I get 0.954. That is the area under the curve from -2 to +2, which is within 2 standard deviations of the mean, okay? So if you couldn't get that to come out of your calculator, I want you to pause the video and try that again, because this is an essential way of calculating for this class, for quiz and test problems. You're going to have to be able to do that. So pause the video, give it a shot. Otherwise, let's move on. So this one is a little different. Data that is more than 2 standard deviations away from the mean, okay? So this is sort of the opposite of this one. Now, if you're quick at it, there's a super quick shortcut where you wouldn't even need your calculator to do that. What's that shortcut? If you remember, the probability for all the events together have to add up to 1. You'll realize that this one is 2 or less. This one is more than 2. So the 2 of these have to add up to 1. So we could subtract this from 1 to get the answer to this. But I don't want you to do that. I want you to do that using the calculator, and then we have a quick check because we can just subtract this from 1 and make sure we did it right, okay? So this one's a little different. You're gonna have to do two calculator calculations. So we wanna do one that's less than 2. So the lower bound, just give you a walkthrough here. The lower bound is negative infinity. The upper bound is -2. And then we have our mu of 0 and our standard deviation of 1. So here are your parameters. Minus infinity to -2. That gathers this part of the curve. And then you'll have to do the same thing for positive infinity, or from +2 to positive infinity. So go ahead, pause the video, and do that calculation. All right, when I do that, here's what I get. When I do it for the lower bound, I do this particular math right there, I get 0.022 rounds up to 8. So that is for this portion. Now I can save myself a little grief because I recognize that since this is a symmetrical bell-shaped curve, the area under from 2 to positive infinity is going to be the same as from -2 to negative infinity. So I just multiply this value by 2 and I get 0.455. So it's 4.55% chance that a randomly selected data point will be greater than 2 standard deviations away from the mean. Now check it out. This makes sense because here is 2 or less away, here is more than 2 away, and if you add these up, you're going to see that you're going to get just about 1. And the difference between this and 1 is a rounding thing. So We confirmed that that's good. Okay, 2 more. Now these I'm going to give you a little less guidance, a little less prompting. I'm not going to go ahead and tell you what to put in. I'm going to leave that for you. So what I want you to do is pause the video and do this one. Find the area under the curve for data between 1.5 and 2 standard deviations away from the mean. So you want all the data that's further than 1.5 and less than 2 standard deviations from the mean. So pause the video and get out your calculator and give that a shot. All right, so here's the calculation. I'm going to do it in the positive area first. So that's going to be to the right of that mean, which is 0. So my upper and my lower bounds in this case are going to be, where are we at? We're at 1.5 and 2. So I'm going to put in 1.5 and 2 for my bounds. My mu is 0 and my standard deviation is 1. When I put that in the calculator, it tells me back 0.0441. Now this one is also symmetrical because we're just doing it from 1.5 to 2 in positive. That would be roughly from here to here. And then we want from negative 1.5 to negative 2, about from there to there. So that's just going to be the same. So I can just multiply this value by 2 and get 0.45. I'm sorry, back it up. Multiply this value by 2 and get 0.0882 or 8.82%. Now, one last one. And this one's maybe a little more tricky, maybe not. See what you get. I want to see the probability that randomly generated data will fall within this range for standard deviation. It can't be further away than negative 1.75 standard deviations, and it can't be further away than positive 2.12 standard deviations. So go ahead, put that in your calculator and see what you get. This one's actually pretty straightforward. I just have different bounds. So my lower bound is going to be minus 1.75, my upper bound is 2.12, but I can put those in the syntax in my normal CDF command line or in the menu system, and I'm going to get out 0.943 or 94.3%. Now, check that out for reasonableness. Does that make sense? And I think you'll find that it does. The data between 2 standard deviations is 0.954. Now we came in a little bit this way, so we're going from 1.75, but we went to 2.12. So we're very similar. You can tell here just a little bit less, like basically a percent less, 1.1% less. So the area under that curve is just a little bit less. But otherwise, we're almost identical. So I hope that helps with this lesson on normal standard distribution and using the calculator and the curve and all of that. But if it doesn't, you can just ask me a question the next time we have class. Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also, remember that you can come back to this video, watch it again if you want to deepen your understanding or fill in any gaps. Lastly, if you enjoyed yourself, please click like or subscribe.